you to learn, there was one thing, more than anything, that I wanted you to learn this semester. Let's see if you learned it.
Semester?
This summer. Let's see if you learned it. Tell me something you've learned this summer. Yes?
How to make like the water put like this and the baking soda to change color.
Okay, that was a good thing. But that's not the thing I was hoping you'd learn. Yeah?
Chemistry's hard.
Chemistry's hard, that's what you learned? Okay, that's not what I wanted you to learn, but yeah?
That there's lots of different ways chemistry works.
Okay, very good. That's something that you learned.
Electron configuration.
Ooh, that's something you learned, but that wasn't the thing I was after.
Solubility rules.
No, that's a good thing, but I wasn't after that. Any other ideas?
The basics about the atom.
Basics about the atom, what's that?
How the molecules are made.
How molecules are made, that's a good thing.
Ions, ionic compounds.
Ionic compounds. What's the other kind of compound?
Molecular.
Molecular compound.
Then polyatomic ions.
Polyatomic ions. Ions in general. All good things. What I wanted you to learn, hopefully, is that chemistry is not scary. Did you learn that?
Yeah.
Okay.
Yeah.
Because you're not staring.
Chemistry's not scary. So when you come to the point in your life when you have to take a chemistry class, you will hopefully say, I'm not afraid of that. That's easy. Or not easy necessarily, it's not easy. But it's doable. It's not impossible. And it's not scary.
And you were scared
My
of that.
sister should have learned that.
Alright, so that's what we wanted you to learn. Now, let's get back to electronic configurations. For example, let's look at the electronic configuration of copper.
Can we do
Copper.
noble gas?
Well, let's do copper really quick.
29.
Here's copper, electronic configuration of copper. And now
Are we
remember,
going to use the grid?
what?
Are we going to use the grid?
The grid, what do you mean?
How we have, yeah, that.
Yeah, because if we draw the atom, it's what?
Great.
It's too
Messy.
complicated. It's too messy. You can't tell what's going on, right?
I'm like,
So we're going to draw this
that's
grid.
copper.
And you know what? I'm going to even simplify it further. Instead of starting with 1s, 2s, 2p, 3s, 3p, instead of starting like that, I'm going to take copper, look at copper, and then go backwards until I get to the first noble gas.
Backwards,
Yes, counting down until you get to the first noble gas.
which is helium.
Helium? Are you sure?
The first noble gas. Neon.
The first noble gas before copper.
Oh, the first noble gas. Argon. What is argon?
Argon. Argon. So here's what I'm going to do. Instead of starting off 1s, 2s,
You're
I'm
gonna
just
go
going to
for
go.
argon.
I'm going to go like this. Argon. An argon core, right? And then what? What's next after argon core?
Argon.
Tom, kid, put that away. There's no way you can do two things like that at once.
Argon
But,
is 4s.
so we,
After
why don't you
argon,
draw
4s.
everything to argon?
I could, but it just takes time. So I saved ourselves some life seconds by saying argon. Now we move on. What's next?
4s.
So you look at argon, and what number is argon?
18.
18, and then look at number 19.
4s.
It's in what row?
4.
The fourth row, and that block is the S block, correct?
4s.
Let me grab a periodic table here as well.
Yes.
You guys know where the S block is?
It's these. It's
Point to the S block on your neighbor's periodic table.
It's the alkali metals and the alkali earths.
That's right, it's this block right here. That's the S block. Okay? S block. So, 4S, here's my 4S.
Then 3D.
How many electrons in the 4S?
2.
2. 2 electrons in the 4S.
3D.
And then 3D. How many orbitals does the 3D have?
How many orbitals?
How many electrons across?
10.
10 electrons. And so that's 5 orbitals. Here it is, I drew it. 3D, 5 orbitals across. How many electrons are there for copper?
9.
9?
All but
So
one.
we go 1, 2, 3, 4, 5, 6, 7, 8, 9.
And then,
Correct?
and then if you tried to mix it, it would lose 2 because it wanted because it would lose its 4s.
Yes.
But
It loses the 4s
Wait,
and
why
forms
did
a
you
copper
draw
plus
6? I forgot.
6 what?
6 little lines.
I didn't. I drew 1, 2, 3, 4, 5, 6, 7, 8, 9.
No, lines that the little things go with.
1, 2, 3, 4, 5. There's 5. These 5 lines?
Oh, yeah.
There's 4s is one here, and then this is the 3D.
Oh, it's 10.
A little bit. A little bit. That's almost always it's
Wait.
plus 2.
So copper. So copper will either go.
Copper will want to
It will either
lose
lose
4.
2 for 4s, or it'll lose 6, or losing 4s and getting symmetrical.
Yeah. But it doesn't end up doing that. It doesn't lose 6. Something happens when an element has to lose a lot of electrons. Can you imagine what might happen?
It explodes.
It gets unstable. It gets unstable, right? Because all those positive charges are like in the nucleus. I need more electron density, please. Right? And so you get rid of too many electrons, and it doesn't stabilize it. What?
That means it would need to share electrons with somebody.
Yeah.
It would need to share one to get.
So
So
let's
if it
look
wanted to
at
get
our
more
next
stable-
element. Let's look at our next
So
element.
if it wanted to get more stable, it would have to gain 1 electron.
What? Copper?
Yeah. If
No,
it
it doesn't stabilize itself that way.
I'm saying it could if it
Yeah,
happened.
that's an interesting
If it
idea.
happened.
That's an interesting idea.
It
Maybe
would,
maybe you could
If
find.
it happened, it would.
I mean, I haven't seen that kind of chemistry, but that seems to be like something they would like to do, huh?
Like copper, sodium. Sodium, they could share electrons. Copper doesn't share.
Yeah, generally that's not the rule, but who knows? Maybe in the future somebody will figure out compounds where that can occur under certain circumstances. Okay, but copper likes to form a plus 2. A plus 2.
Plus 2 ions.
Just to lose his 4s.
Yeah.
That's what
Okay.
most elements.
It can't find symmetry here very well, right? Alright, let's
Well,
do
he
chromium
could just
now.
lose 1.
Chromium.
So
Well, let me see your where I got the character.
chromium CR. Chromium CR.
Let's do
Can we do?
molybdenum. Molybdenum.
So
And-
are we ever going to do the green and reds?
Krypton. Krypton is the closest one.
We're doing molybdenum first. Let's do molybdenum first, then we'll try to do one that includes greens and
So we
reds.
need
Okay?
to.
Molybdenum. So this
Krypton.
changes, correct? Molybdenum. What number is molybdenum?
42. The closest noble gas is Krypton.
The closest noble gas
Oh, that
is
blew up.
krypton. K R. All right. And then what's next? After krypton, what's the next element if we're working our way toward molybdenum?
5s.
What?
5s.
5s. How many electrons are we going to put into the 5s?
2.
2 electrons. And then what's after 5s?
5s is 4D.
4D. 4D. Now, why didn't we call it 5D? It's really in the 5th row, right? Why did we do that?
Well, it's
But
some
because-
crazy electron thing that
Because this has Oreo. Oreo.
Oh,
I'm
it's
taking
because
it out.
it doesn't have as much energy as
Yes. Some crazy rule doesn't have enough energy. Has much energy. So 4D is the answer.
It has
4D.
4.
And we have 1, 2, 3, 4, 5 orbitals in the
And it
4D.
only has 4.
Four electrons altogether?
Yep.
1, 2, 3, 4.
Why do you even need 5 if you only have taken 4 out? Why do you even put 5?
Oh, 5 orbitals?
Yeah.
Well, you should always put all the orbitals so you can think about what the symmetry needs to look like, right?
Okay.
So if you
So
add
it lose
more,
2? But like copper, that won't lose 6 because that's too much.
That's right. That's right.
So the only way it can get stable is if we use lead.
Like that.
Yes.
There couldn't be 5.
5 what?
There couldn't be 5 lines right there because there's only 1, 2, 3, 4, 5, 6, 7, 8, 9.
Let me see. Well,
The red and green.
Those
oh,
are
oh, no.
the red
Oh,
and greens are a
molybdenum?
different thing. No,
Oh, we're
he's
talking
about the 2 rows there.
Hold on. So you're saying if we were doing something like osmium, there's only 9? Yes, you're right, and that is embarrassing. And I'm not going to talk about that because I'm embarrassed about it. But there's another little tiny exception in there that comes into play.
Shoe?
Yeah.
Shoe?
Okay,
Tim,
so
these have their own type of center.
I think, in fact, that's where we're going to stop doing orbital diagrams.
Yeah,
to
five
predict the kinds of
minutes.
bodies. Okay?
I thought we were gonna go into the lanthanides.
Well, we can do one lanthanide just to get a little bit of an idea, I guess. How about gadolinium?
No, that's what I was talking about. How about that?
Aha. I got you thinking.
I was.
Gadolinium. Let's go to gadolinium.
The closest noble gas is.
Tim, can you see the closest noble gas for
Axion.
gadolinium?
What number is it?
What number is gadolinium?
Axion. It's 64.
64.
And it's Exxon. Exxon or Xenon? Xenon. How do
Xenon?
you want to say this?
All right, xenon. X, E. Xenon. Gadolinium.
The closest one is.
That means it goes to 6S after that. Oh, yeah.
6S. All right.
Then it goes.
After xenon, we have 6S.
So it'll
And
go.
then what's after 6S?
It'll go to the F's, right? It'll go to the F. The F or F, right?
Uh-huh.
But we don't know. Does the F type have the same energy problems, or is it actually?
It has.
6S?
It has. Okay, everybody listening well now?
Does it
The
have
next
twice
after
as much?
6S, you see what's after 6S, Brady? Where does it go next?
Success. Success should go to 6.
We have 2 electrons in 6S.
That's not T.
It actually goes to the green. See the green? See how that little green dot is there, Tim? That green dot
Would
is
that
saying
be
it goes
4F?
to the green.
Would that be 4F? Would that be 4F? No, it would be 6F.
Huh?
No, it's 6. The D
F,
is the one
F.
below.
So the F is the green.
The F has a 5F.
So after 6S are
6F.
5 or 4F. 4F. It's actually depressed by 2 numbers. So even though it's in the 6th row, because it's F, it goes. How many orbitals are in the 4F?
12. It has 15 elements, so it should have 8 orbitals? 8? Yeah.
All right. So here's the deal. Here's what Tim's question was. Here's what Tim's question was. Lanthanum, and actinium, 57 and 89. Those ones actually belong up here in the D orbital. Does that make sense, Tim?
And then with that out, it will be a 14, so it will be a 7
Yes.
without those.
So for what are we drawing again? Gadolinium. It actually goes like this, which is kind of weird. 6S, 5D, 4F.
I can't see.
5D, and we get 1 electron in the 5D, and then we start filling the 4Fs.
Which has 7.
1, 2, 3,
What did
4, 5, 6,
4F look like?
7.
What do 4F orbitals look like?
I don't know.
Figurine?
No, I think they look very similar to these.
But which
Maybe
is
more
more?
lobes. And then how many in there
8.
for gadolinium?
8. So it has 1 extra.
7. 1, 2, 3, 4, 5, 6, 7. Because there's 1 in the 5D.
Oh, yeah.
Okay?
So it's even, it's symmetrical.
It's even and symmetrical, and it could lose 2, or it
Or
could
1.
lose
Yeah, it'll probably lose
3.
1. Or
3. These
One
are the
or
2 that are
two.
going to go first. The ones with the higher number, 4, 5, or 6, the ones with the higher number are going to go first.
okay.
Okay. How much time left?
1 minute.
1 minute.
Less, actually.
Yeah.
Okay, so let me tell you a story. My wife went to the store yesterday. It was so nice of her. And she said, I bought you some iron oxide. And I was like, what do you think I said?
Awesome. That's Russ.
Was it iron 2 or iron 2?
That's right, that's what I said. Iron 2 oxide or iron 3 oxide. Because iron forms a +2 compound or a +3 compound. Iron 2 oxide is FeO, like that. Iron 3 oxide is Fe2O3. So she said she bought me some iron oxide, but I didn't know what she was talking about. What she needed to say was, I bought you some iron what?
Iron 3 oxide.
This is iron
Iron
3.
2 or iron 3
And this is
oxide.
iron 2. How do I know this is iron 2?
Because it has a +2 ion.
Because in this ion, in this compound, the iron is a +2 ion. Whereas oxygen is always a -2, right? But in this compound here, iron is a what?
+3.
A +3, and oxygen is still the -2.
Which is why it needs 3
So there's 2 of those necessary and 3 of these. Does that make sense?
Yes.
No?
Yes.
Do you understand it? You don't? So this is iron 2 oxide. We call it iron 2 oxide because the charge of the iron is a +2. But in this compound, the charge of the iron is a +3. So we call it iron 3 oxide. So my wife came home yesterday and she said, I bought you some iron 2 oxide. Then what do you think I said?
Oh, that's rust.
No, what do you say when somebody buys you something?
Thank you.
Thank you. All right, very good. So now we know how to differentiate between the different kinds of compounds. Iron 2, iron 3, molybdenum 2,
Done.
molybdenum 4, based on the charge that the cation or the metal has.
We're done with this
The
lesson
end.
or done?
Done for today. See you tomorrow, the last day